hopefully this won't take the whole rest of the period. Then I can let you guys get started, and then if you have questions, I can help you. Okay? So we're finally almost done, right, with the linear systems, solving linear systems. You've learned 3 methods, right? And the elimination method has taken the longest because the elimination method is often the easiest method. It's not always, but it's often. And it's such a great thing to know all the ways that you can use it. And in order to use it, sometimes you have to manipulate equations, like you've learned. Like last night, you realized you could manipulate one of the equations. Okay, but now let's look at this problem. We use our same technique that we used before last night. You look at the numbers in front of the x's, you look at the numbers in front of the y's. Those are called the coefficients, right? The coefficients, all right? And you look at the smaller number in front of the x, it's a 4. And you ask yourself, can I multiply 4 times any whole number to get 5?
Nope.
And hopefully you all said no. And then say, okay, well, then I'm going to go to the y's. And you look at the y's and you say, can I multiply 2, the smaller number, times any whole number to get 3?
No.
No. Oops. So what I did last night doesn't quite work. So then does anybody have an idea?
1.5.
Okay, how about Thorn?
Then you multiply both equations by their reciprocal.
Very, very, yeah. The only question I would say, the only thing I would change is the word reciprocal. But you're totally right. I know exactly what you're saying. You saw it. If you want these numbers to be the same number, right? Only one of them positive, one of them negative, right? So if I wanted to eliminate my x's, I could just multiply the top equation by 5, because 4 times 5 is 20, right? I could multiply the top one times 5 and the bottom one times negative 4. And then I'd have a positive 20 and a negative 20. Does that make sense? Right? You said reciprocal, but reciprocal would be 1/4 and 1/5, right? It was just misusing the vocabulary, but you were totally right on. It was brilliant. All right, but I could also choose to do this one. So sometimes these numbers are really big in front of one of them, and the others are really small. Use the smaller numbers, right? Don't use, like, when you have 17x and 33x, don't do 17 times 33, right? Do the 2 times 3 or the 3 times 2 or whatever, right? Do ones that are easy, right? So yes, what were you going to say, Gabe? What would you do if you wanted to eliminate the y's, what would you do?
Multiply by negative 1.5.
Okay, that would work. That would totally work. But in general, it's easier to just multiply by a whole number, right? It's just easier, right? Because I don't know what 1.5 times 5 is. I don't know what 1.5 times negative 11 is, right? I can't do that really fast. Yes, I could do it. I can figure it out. But I do know what 3 times 5 is, and I know what 3 times 2 is, and I know what 3 times 11 is. And I know what 2 times that is, and 2 times that is, and 2 times that is. Fast. You see what I'm saying? It's quicker to do something with whole numbers, I think. But if you want to do that method where you use decimals, it's fine too. It works. Totally works. You might be this decimal lover, right? You might be in love with decimals. And if you are, go for it. It's totally fine. But for most of us, it's easier to use whole numbers because it's faster, right? I don't have to calculate. I don't have to waste my time calculating. So it means you're going to multiply both equations. Does that make sense? Instead of just one equation. Yes. Sorry. Oh, go ahead, please. Yeah, help yourself. I mean, do whatever. I guess just, I don't know, take it out. Sure. Just don't burn yourself.
Don't burn yourself. Take it out.
See that?
Or, yeah, here comes.
It's not burning.
You're okay.
Okay,
It just
we're
smells
okay.
like it, but the paper's not burning.
We're cooking paper.
Yay.
Okay. All right. So
Lunch today.
we at our school, we do very unique things.
That's
We
for
cook
hot
our
lunch.
paper.
The paper's hot lunch.
Make sure you cook your homework every night. Okay. So, all right.
We bake paper and eat it.
So we have 2 choices. when you are multiplying both equations, you have a choice. You can do either one. You can multiply this one times that number, and this equation times that number, or you can multiply this equation times this number, and this equation times this number. But you want to make sure that one's positive, one's negative, right? So, okay, let's try it. So which one do you want to do? You want to eliminate the x's or the y's? All those in favor of y's. Okay, we're going to do the y's. All right, they're both negative, so I know I'm going to have to multiply one of them by a negative number, right? 2 times 3 is 6, so I want it to say 6y, right? 6y and negative 6y. All right, so which one? So we'll just, how would I turn this into, we'll just make this a positive. How would I turn that into a positive 6y?
Multiply by negative.
Negative 2, right? Negative 2. All right, this one, I want to keep it negative, so I'm going to multiply it times a positive number, and it's going to be that number, the 3. You're just, that number's here, that number's there. And you have to make sure you get the right negatives, right? That's the only thing. That number's there, that number's there. Easy,
Oh.
right?
Yes.
It's really easy,
Yeah.
right? And then, so now you just multiply it out. But don't forget, you got to multiply everything. Negative 2 times 4x is negative 8x. Negative times negative is positive. So negative 2 times negative 3y is positive 6y equals negative 2 times 8 is negative 16, right? All right, here we go. 3 times 5x is 15x. 3 times negative 2 is negative 6y, equals negative 33. You with me?
Yes.
And now we're just going to add them together. So what is 15 minus 8?
7.
7. So we have 7x. Those cross out, right? So
Yes.
7x is equal to, now what would that be? Negative 16.
49.
Wait,
So,
what? No.
would you say? Say it again.
49.
Negative
Would be negative or positive?
Oh, yeah.
Negative 49, exactly. Good. Negative 49. 7 goes into 49 easily. That's perfect. Okay. All right, divide by 7, divide by 7. X is equal to
Negative.
negative 7. Always slow down when you see a negative 7. Ask yourself twice, what is the answer, right? Negative 7. Because if you said 7, I guarantee everything's going to be wrong from here on out, right?
Yes.
You don't want to mess up here. Okay? So then, so now we just have to plug this back into, not these equations, to one of the two original equations. It would work if you did these. But the rule states, because what if you made a mistake on these, right? You might have made a mistake. You might have put negative 9x here, right? So you don't want to plug it into this because it might work. And then you'll think, oh, I did it right. You want to plug it into the original equations, one of them. I'll use the second one because I've been always using the first one. So we'll use the second one. 5x minus 2y equals negative 11. Now that says x is negative 7, so I'm going to replace the x. 5 times negative 7 minus 2y is equal to negative 11. What do I have? Negative 35, right?
Yes.
Minus 2y equals negative 11. Right? Can you see? Okay. Realizing I'm in Henry's way. Plus 35. I have negative 2y is equal to negative 11 plus 35. That's the same as 35 minus 11, right? So it's 24, right? Negative 2y is equal to 24. Divide by negative 2. Divide by negative 2. Y is equal to negative 12, right?
Yes.
Okay, so my answer is negative 7, comma, negative 12. All right? Now, Sevi, so you got to go. Sevi, let me give you the homework. Are you going to be back? He's going to come back. He's coming back? Let me just give it to you so you have it. And then, just put it in your ledger. All right. So again, I could have done it. I could have eliminated my x's instead. I would have gotten the same thing. But if I had eliminated my x's, I would have solved for y first, and then I would have plugged this in to one of these equations, and I would have gotten this last. Does that make sense?
Yes.
Okay.
Can we do our homework?
So, do you want me to do one more, or do you want to do
No.
the homework?
Thank you, Curry, for
All right. So we're over. The